The Bernoulli distribution is the simplest discrete random variable one can consider. The Bernoulli random variable models the outcome of an experiment with two possibilities. And even though we encode these possibilities here as 1 and 0, the interpretation of these labels could be, for example, success and failure of an experiment, or heads and tails in a coin toss, or whatever you actually have in that particular application. So the Bernoulli random variable takes the value 1, or it results in a success of the experiment with probability theta, and it gives a value 0 with probability 1 minus theta. The important thing to remember here is this notation right here at the bottom, which we read x, the random variable x, follows a Bernoulli distribution with parameter theta. Now this symbol right here is what is read follows. And what you have on the left of this symbol is a random variable, and what you have on the right is a distribution for that random variable. So the distribution, if you like, is the law, the probability law that the random variable is following. Let's look at the probability mass function of a Bernoulli random variable. Of course, by definition, we have that the probability that x is equal to 1 is theta. And from the application of the obvious rule, we can find the probability that x equals 0 is 1 minus the probability that x equals 1, which is, of course, 1 minus theta. Now, let's calculate the expectation of the Bernoulli. We have by definition that the expectation of x is the sum of x times the probability mass function of x, which here is 1 times the probability that x is equal to 1 plus 0 times the probability that x is equal to 0. And of course the probability that x is equal to 1 is theta, and the probability that x is equal to 0 is 1 minus theta. So we're going to get that the expectation of x is theta. For the variance, we need to use the formula that states the variance is the expectation of the square of the random variable minus the square of the expectation. We already have the expectation, so we need to find the expectation of the square of the random variable. And this, by definition, is the sum over all the values of x squared times the probability mass function of x, which is here 1 times theta, which is the probability that x is equal to 1, plus 0 times 1 minus theta. Of course, this 1 is squared, which is the same as 1, and the 0 is squared, which is the same as 0. And this is going to give us, again, theta. Plugging everything in this formula, we get that the variance is theta minus theta squared, which can be written as theta times 1 minus theta. Now, I would like you to pay a little bit of attention on the fact that the expectation of x is not a value that x can take. To visualize this, let's consider the probability mass function. We have here, say, 0, and here we have 1, the two values that x can take. And the probability of 1 is, of course, theta, and the probability of 0 is 1 minus theta. Now, if you look at the expectation of x, you will see that it is a value somewhere around here. Of course, this distance is also theta, and you can clearly see that the expectation is not any value that the random variable can take.